when it comes to data, we like mean, median, and mode, and standard deviation and stuff because it tells us a lot about the data. It tells us, where the middle is and how spread out the data is and all that. But a lot of times, where the data came from is just as important. First of all, we got to look at the sample. The population is going to be the big group of all the people that you want information about, and the sample is going to be the subset of the population that you end up using to collect data on. We don't, if we want to find the opinions of all high school people, we don't actually survey every single high school person in the entire world. We take a subset of that, we take a sample of that population, ask them questions, and say, well, since most people in our sample answer this way, we can apply that to say, well, the entire population would probably answer that same way at the same rate. But the way that we select the samples could be different. There are 4 different types of samples. The first one is a self-selected sample, and that's where the members volunteer to be a part of the sample. The next one is a convenient sample where members are chosen because they're easy to reach. Now this might be a motivational speaker standing on stage and wanting to get the opinions of his audience, but he only asks the people in the front row because they're closest to him and it's easiest to get that information from instead of wandering all around the room and getting a better sample. There's the systematic sample in which you use a rule to select the members. So if we're talking about all high school students again, maybe you really want to know about football players, or questions about football in particular. So you only ask high school students who are in football, and then that starts to apply a rule to whittle down the population from everybody to a smaller sample. And then lastly, there's the random sample where each member has an equal chance to be selected. Maybe everybody's assigned a number and you start picking numbers at random or you roll dice or something. Now, let's say that a sports writer is surveying, college football coaches because he writes an article on college football. And he wants to get some opinions from all the college football coaches. Now, what if that sports writer only surveys the ones that he has in his phone? So only the ones that he can call. What kind of a sample is that? Well, because he's only getting in touch with the ones that are easy to get in touch with, that's going to be a convenience sample. Didn't really go out of his way to get a large sample, just the ones that he has in the phone. But what if now that sports writer actually types up a survey, sends it out into mail to all college football coaches, and then only uses the responses that come back? Well, because he's only using the ones that come back, that means they're self-selected. So the coaches that don't want to be a part of the survey aren't being a part of the survey. It's only ones that want to be, so they're selecting themselves to be a part of that survey. Now, the problem with a lot of ways that samples are created is that it might introduce bias into the data collection process. Now, a biased sample is one that represents one population too much or too little. For example, if I was trying to do a survey to understand people's views on the price of gas, but I only selected a sample that contained bike riders, their viewpoint would be overrepresented, whereas the people who actually drive cars is underrepresented, and obviously that bias would not produce effective data. Unbiased sample is going to be one that's representative of the whole population. So, on the flip side of that, asking about the price of gas, I would want to ask people who drive cars and people that don't drive cars so that we can get a more representative sample of the entire population. So let's say the manager of a club wants to know how often people in the community go to concerts. So she goes outside and asks the 50 people standing in line before a show how often they go to concerts. Well, first of all, what kind of a sample is this? It's convenient because she's just stepping outside the door. It's not like she's going out into the community to ask a wide, diverse sample. Now, is it biased? It is, because the people that she's asking are people who are already going to a show. that represents, concert goers much more than people who don't go to concerts. So that's the bias that is there. How could you make it unbiased? Well, the best way to get an unbiased sample is to take a random sample of the entire population. So this club manager would have to, create a survey and, administer it to random people throughout the entire community, and that's going to include, people who don't go to concerts, people who do go to concerts, young people, old people, men and women, everything would be included in that sample to make it unbiased. Now, let's say that we do get a nice random sample, and it's unbiased, and we create this survey that's really nice and everything, and we got a well-represented data, some well-represented data that represents the entire population really well. No matter what, there's still going to be what we'll call margin of error, which limits how much the responses of the sample size are going to differ from that of the population. Because we're not actually surveying everybody, we're only surveying a small portion of that, we might accidentally, even though we're trying to be unbiased and everything, accidentally get some, people in the sample size to answer a question one way more often than what would happen for the entire population. And that's what the margin of error tries to convey. How we find margin of error? Well, we start off with plus or minus, and then it's 1 over the square root of the number of people that we survey. So if we only surveyed one person, then the margin of error would be plus or minus 1 or plus or minus 100%. Because we would get an answer, maybe yes or no, and that could be what everybody in the population says, or nobody in the population says, or 30% of the people in the population. That's why we need the sample to be quite a bit bigger. So let's say 1,011 people were surveyed, and 50% said their main source for the news was television. What's the margin of error? Well, how we find the margin of error is just saying plus or minus 1 over the square root of how many people were surveyed, and that's 1,011. So it'd be plus or minus 0.031, or plus or minus 3.1%. What that means is, because we only surveyed 1,000 people, that means our percentage of 50% saying that their main source comes from TV news could be off by as much as 3.1%. So, what's the interval of exact percentages for the entire population? Well, to do that, all we do is take that 50% and add or subtract 3.1%. If we subtract 3.1%, we get 46.9. And if we add 3.1%, we'll get 53.1%. So the exact interval is 46.9 to 53.1%.